Isa,
Is he in class now? Isa?
He's here to join.
All right. So what we will do is I will share the course materials with you through Isa, your course rep. Then I'll give you direction as to how you should go about the materials. We have 6 units to cover in 4 weeks. That's 4 meetings. That will mean you have to do reading on your own, so that when we meet, areas in the slides and the materials that you are struggling to understand, you will let me know. Then we discuss. So I will not entirely do unit by unit teaching, because when we do that, we can't finish, considering the time that we have at hand. So you will do extensive reading within the week. Then on Sundays when we meet, areas that we need to focus on, we do that. But this sounds a good idea for us to go by. Is it a good plan?
yes, Doc.
Yeah, it's okay.
All right. So today what we will do is that we will discuss the course unit, the course outline. Then we tackle the unit 1 together. Then I give to you unit 5 to 6 and show you how you go about it. So I believe you can see my screen.
Yes, sir.
Yes,
Yes, sir.
Doc.
Yes, we can see.
So it's important you know what the course is about and what is also required of you to do. Um, yeah, so the course information is the title is Advanced Algebra and Calculus, and the course title is EMA202. It is a 3-hour credit course, and the delivery is actually blended, both face-to-face and online. But for you in particular, you will be doing only the online. There are other centers that will be doing both face-to-face. And our meeting time is on Sundays, 7 to 11 a.m. and that makes it 4 hours. So within 4 hours, we can do a lot. Then these are my information. So if you want to reach me, this is my contact number. This is also my email. When you come to campus and you want to locate me physically, you come to Department of Mathematics and ICT Education. It is at the old site. And my office room number is 3. So anytime you come to campus, pass by and let us have fun. Prerequisite to this course is elective mathematics for senior high school. So I believe all of you here have read elective mathematics. In addition, This course also has some relationship to some of our undergraduate courses, Mat 102 and Mat 203. So it's likely during your diploma level, you did these two courses. Required textbooks that you'll be using. You'll be using the SHOMS, Outline of Theories and Programs of College Mathematics. Then we shall also use the college algebra authored by Ten and his colleague. Then if we also use calculus, that's the early transcendentals, authored by Stewart. In addition to these three required books, these are additional materials we will be using. Engineering mathematics, authored by Stroud, and also Advanced Mathematics 1, authored by Ten and Co. So these are our reading materials for the course. I'll make some of them specific pages that you can also read for your extended reading. I've also prepared slides from Unit 1 to 6, which cover the area of focus of this course from these materials. Course description. We are preparing you for senior high school mathematics, and therefore it's important you develop conceptual understanding of the algebra component of the SHS math curriculum, as well as the calculus component of the SHS mathematics curriculum. In addition, your level of understanding of the topics in these focus areas should be higher than that of the SSS. So many of the topics will go deeper than what you have done at the SS level, or you are expected to go and teach at the SHS level. Hence the title Advanced Calculus and Algebra. So the course focuses on developing the understanding of algebraic concepts, and also introduce you to some advanced topics in calculus. It will build upon the foundation laid in the senior high school mathematics. So we have done, that's why I said that the prerequisite is the SHS elective maths. If you've done the elective maths at the SHS level, then this course should be cool to you, because that will serve as the basis. Particularly, we shall focus on set theory, logical reasoning, relation and function, series convergence, mathematical induction, differentiation and integration technique. And as indicated earlier, the course will also build your knowledge and skills of teaching algebra and calculus content in the SHS school. So we expect that by the time we finished, you'll be able to apply set theory in solving problems. You'll be able to explore the concepts of relations and functions and their applications in solving problems. You also apply the knowledge of arithmetic and geometric sequence in a variety of contexts, and we mean real-life contexts. You will also be able to determine convergence or divergence of a series. Objective number 5, you'll be able to express a series in a partial fraction and apply it to find the sum of the series. Number 6, we'll be able to prove some mathematical relation by means of induction. Objective number 7, we'll be able to determine the validity of given statements. Number 8, we'll be able to evaluate the derivative of a given algebraic function from the first principles. What am I? Yeah, my network. I believe I'm back. Hello?
Yes, sir. Yes, sir.
Right. So, which objective did we get to that I went off?
So we got to 9.
Oh, all right. Yeah, so the 9 is to evaluate the derivative of given functions. Then number 10, you should be able to evaluate the integration of given functions. So this is the course content. And course content, we mean the topics that we will be focusing. So we shall focus on algebra of sets. And in the algebra of sets, we will be concentrating on description of sets, ways of representing a set, operation on set, De Morgan's law, differences of set, power set, partition of a set, Venn diagram. Then unit 2, we will consider relation, mapping, and functions. Under that, we'll look at definition, types, Cartesian product, equivalent relation, interjective, composite function, inverse of a function, then piecewise function. Number 3, we will look at the linear and exponential series. And in that, we will focus on the nth term of an AP and GP, the sum of first n terms of AP and GP. We shall look at intuitive treatment of convergence and divergence series. And under the convergent divergent series, there are types. So we have the comparison method, we have ratio and root test method, then also partial fractions. Unit 4, we will look at logical reasoning. Under that, we will look at valid argument and truth tables. Unit 5 will be mathematical induction. Unit 6 will be differentiation, and under that, we will look at limits, differentiation of algebraic function from the first principle, methods of differentiation applied to algebraic trigonometry, and also logarithmic function. Then our last unit will be integration. And under that, We look at definite integral, indefinite integral, as well as definite integral, area under curves, techniques of integration. And under the techniques for integration, we will focus on substitution, that's algebraic substitution, trigonometric substitution, partial fraction, and also integration by parts. So these are the areas we shall cover. That means when you lay your hand on any algebra book or any calculus book and you are reading, focus on this content. In addition to the slides that I will give them to you. So our instructional approach are going to involve talk for learning, brainstorming. We shall also use some simulation and animation, with a technology based instruction. We shall also include collaborative learning, think, pair, share, small group discussion, whole group discussion. Assessment, you do, by the practice in code, you will do 2 quizzes. And in class 2, we shall also be doing some activities that form part of our assessment. So in all, the continual assessment constitutes 40%, end of exams will constitute 60%. You need to get 50 or better to enable you pass the course. Academic integrity. Yeah, so once you gain admission into the university, you are required that you will be honest in all your academic activities. So by joining the University of Cape Coast community, students express their willingness to accept the responsibility and privileges of the academic community. So you have some freedom to enjoy, like I'm teaching you. It's your freedom. I have to teach you. It's your freedom to use our facilities once you have paid your fees. But you also have other responsibilities. Your responsibility include attending lectures regularly and also punctually on time. You have to conduct yourself well by showing respect to your own colleagues and also to your lecturer. And also showing respect to the authority. Where you have issues, you let us know in a polite way so that we all find a way of solving the problem that you have. We are there for you. So you don't need to be afraid when you have problem and you need a solution to the problem. However, you still need to be very, very responsible. Issue about submission of assignment, participating in quizzes, you have to do. Failure to do them, you score 0. You score 0, and that will mean you fail the course. Okay. Now, the 4 weeks we are going to engage ourselves, we are human beings, so sometimes it's likely that I may treat you unfairly. So whereby you feel that I have treated you unfairly, you can reach out to the department, the head of department, to seek redress. But I feel that when you feel mishandled, it's important you discuss with me first, so that we iron out our issues. But when you still feel that I've not been able to handle you fairly, you can see the HOD, then both of us will go, then we will solve our issues amicably. And the HOD, if you still feel that you did not get the solution, you can still move to the dean of the faculty. Then if over there too you still feel not comfortable, then you can reach out to the vice chancellor. Then we all come, then we look at the issue, then we solve it. That will mean that you don't just stand up and report issues beyond me. Let me know first. Then we all judge about it, and then we go forward. I don't want a situation where issue will reach top there, I have no clue. So that is why we have the course policy. And the course policy is very, very important. It serves as a legal document. So when you don't follow it, it becomes problematic for all of us. So kindly take note. Academic amnesty is important. So any form of plagiarism, we don't entertain. Don't go and copy your friend's assignment and submit it as your own. No. Ensure that when you are submitting assignment, you write your index number. Don't go and do assignment for your colleague. We don't entertain that. When you are found, and usually we find it out. Usually. We have been in this game for a long time. So sometimes you may do something, you will never know that we are ahead of you. So please do the right thing. Don't attempt to cheat in quizzes. Don't attempt to cheat in examination. If you are found, it can lead you to dismissal or fail in that course. So I've talked about attendance already. Ensure 100% attendance. If you don't submit your assignment early, the scoring will be capped 80%. And usually I'll do it by 20% each day that the assignment delay. So if your assignment delay 5 days, it means you have scored 0. That's the meaning. Mobile phone, you are online, so I don't have any problem. Appearance, dress well. Especially since we are using technology, the way you use your camera is very, very important. Sometimes students will be on their bed naked, and before they realize, they have clicked on the camera button, and all of us are seeing what we don't want to see. So be cautious of that. Be very, very cautious of that. And one thing I want to also add is this. We would like you to be active in class. And active, we mean sit behind your table with your pen, your calculator, and a book, so that you'll be writing the discussions that we are having. The slides are skeleton and sometimes doesn't contain enough. So it is when we meet that we do detailed discussion. So there are some of you, you log in all right, you'll be lying on your bed and you'll be listening to me like a radio, like that means you are not in the class. You put your phone beside your pillow and you have tuned me on. I'm the presenter on the radio and you are listening to me. No. That will mean you are very passive in the class. So always ensure you are sitting behind your table with your needed materials. Ask questions, engage in discussion. And some of you have some tricks. It is only when it gets to questions that your internet will be troubling you. You ask question, you mention somebody's name to respond. Then at that very moment, that person's network is so bad that he will be using that as an excuse not to contribute. So we take note of all that. So let us go by. Yeah, so this is the detail of what we'll be doing as far as the course description is concerned. So the forum is open for any concerns, any suggestions, any contribution. Yeah, Isa, your hand is up.
Good morning, sir.
Good morning.
Thank you very much. We have listened to all what you have said. Sir, we want to also plead with you that sometimes, as humans, we make errors. And when issues of this happen, we try seeing that you forgive us in one way or the other. And sometimes the presentations and other things would have urged or wants to plead if Sundays like this, if we can, sometimes because of the church issues, wanted to plead if we can, you can schedule us within some early hours so that we'll finish and then we'll have to, then some of us will prepare to our various churches. This one is just a plead or a suggestion I want to put across so that maybe in the hours of 5 to 7 or so that people prepare early and then move to their very distance. Even though I know you personally, when I met you at my master's at UCC, how strict you are, say I know, but you are one of the lovely persons I've ever met. So I want to plead that you continue with that lovely show to that. Just a concern. Thank you very much.
Yeah, your observation is well noted. You are using some kind words on me so that I lower the bar for you. But I must also be frank with you that this course we should have used um, 12 times 3 is what? 36, 36 hours to do. So here is the case we are using 16 hours. So we are compressing 36 hours in 16 hours. You can just imagine. And we are meeting for only 4 weeks. You still have your faith, but we still also need to do our academic work to ensure that quality is also enhanced or ensured. Meeting early, closing early. I know I'm getting old though. I don't sleep early. Even this morning, someone has to call me to draw my attention. I have lectures at 7. So bringing at 5 may be difficult for me particularly. But we will still see. If moving forward, I can still do some adjustment, I will let you know. But I want to draw attention that 4 hours, we can reduce it further. Because already we need to work 36 hours. 36 hours work. We are doing it in 16 hours. So you can imagine the lot of pressure on even you. But if you do your reading very well, it will also be very easy for us. You read the slides, we come, and on Sunday, if between an hour of, let's say 7 to 9, we think that we have finished discussing the difficult areas then we can all go and worship. So it will depend on you yourself. Do you agree with me?
Yes, Prof. Well
Yes,
noted.
sir. Yes.
All right. Is it Dominic? Yeah, Dominic, let's hear you.
Doc, please, I want to find out what always Dr. Benny says, don't rely on the slides.
Okay,
But
if Dominic is not ready, then let's have Jacob.
Doc, I'm talking. Oh. Hello, Doc. Hello.
If you are speaking, your mic might be off and we can't hear you. So check your mic if it is muted. Joseph.
I've unmuted.
Oh, network again.
Hello.
We can hear you. We can hear you.
Doc, I wanted to ask. I saw the slides. If we can get any extra materials per the course we are doing, even if there is any book which you can recommend us to go and have access to, so that it can help us to do our researches and then have additional content to the slides you give it to us. This network program ready.
It's not from our end, though. It's from the lecturer's end. Because when our colleagues are talking, you can hear them.
I can hear you now, but I can't hear the lecturer.
It's the same. Even when you were speaking, he was thinking it was from your end, but rather from his end. I can hear everybody speaking.
But I think he has done that already. Or
yeah,
he's not aware. So those who have his number, you should try to alert him so that he can know.
I think that's why he recommended senior high school mathematics. I think elective mathematics and the rest.
These online courses, they should have printed the materials as those who.
There are some of the topics which are not found within that book. So
I'm not talking about the senior high book. I'm talking about the site that they will be using.
All right. Yeah, so we have Dominic. If you want to ask your question, you can ask.
Doc.
Yeah.
I was asking. I saw the slides. If there are some documents that can be recommended for us, or there are some books which we can go and purchase and go through so that we can add more content to the slides. That's what I wanted to find out.
Yeah, so all materials that are required will be made available as far as the course is concerned. So you don't need to maintain any worry.
Okay, thank you, Doc.
Jacob, your hand is up.
Yes, Doc. Please, from the course outline, I saw that the content of the course outline, most of them were in the first one that we did. That is algebraic thinking that we did in the first block.
Okay.
But I want to find out if it's a repetition or we are going to build up on what we did in the first block, because most of the topics are the same things we did in the first block. So are we going to build on that, or it's just a mere repetition?
Definitely, there could be some possible overlap to begin with, but it will be a step up of many of the things that you've done already.
Okay. Thank you.
All right. So if there are no more concerns, then we can begin with the unit 1 right away. Is the course rep in?
Yes, Doc.
All right. So you send me hi on WhatsApp, then I'll forward to you the materials so that you share with your colleagues.
I hear, Doc.
Okay. So unit 1 is algebra of set. So let's have this. What do you expect to learn as far as this unit is concerned? So you can use the chat console in the Google Meet to type your expectation from this course. You see where the chat button is. If you are using a laptop, bottom right. So type your expectation of unit 1, and the unit 1 is algebra of set. Yeah, I'm waiting for your responses. Yeah, Dominic, your hand is up. Okay, so from Samuel Boateng, he's saying, I don't know, he's expected to solve real life program involving traced program. Okay. From Philippe Sante. His expectation is application of two-set and three-set program, proof of set theorem, and De Morgan's law. Okay. Then Justina. She is saying he should be able to work with set operations. Then Youngson, his expectation is to know step-by-step approach in solving three-set programs. That is fine. Then Winnie is saying his expectation is to use laws like De Morgan's, solving set equations, and also Venn diagram. Then T Uniba, so saying at the end, I should be a good program solver in relation to set operation. Yeah, that's interesting. All right, so you all have good expectations. To be able to prove and use set theorems. All right. So you can see that your expectations are in line with what I have here. At the end of the day, you expect that okay. Yeah, you'll be able to describe basic concept of set, establish set identity, and solve real-life problems using set theory. So you can see that these objectives I have here reflect many of your expectations that you have indicated in the chat console. Now I have these activities here. Number 1 to number 7, I have 7 statements here. Your task is this. Put the following are sets. Justify your answer. So you indicate whether the statement is a set or not a set. Then you provide reason for your decision. So the number one, collection of all the months of a year beginning with the letter J. Is it a set or not a set? Yeah, it's a
Dog, it's a set.
and your reason.
The reason is that we said a set is a well-defined collection of objects of the same kind. And so when you look at months of the year, we generalize them as sets. So we can identify those with the J letters. That is January, June, and July. So in that case, it's a set.
Okay. All right. Then the second item. The collection of 10 selected windows. The collection of 10 most talented writers in Ghana. I can see. Is it a set?
Hey, can I speak?
Yes.
Okay, my name is Prince. Number 2 is also a set because they said a collection of 10. That means that among the talented writers, they've selected 10. So 10 is a defined number of members. So I also consider that one as a set.
So that is due.
Doc.
Yes.
Doc, I also disagree to it because 10 most talented writers may differ from person to person. Let's say we can go out there and ask a certain number of people who are 10 most talented writers in Ghana. It may differ from person to person. So I think it is not a set.
Okay.
Hello, Doc.
Yes.
Doc. Please, number 2 is not set because the set is not well defined. I mean, the criteria for selecting 10 most writers is not given.
Okay.
Doc, can I come in?
Yeah, you can.
Doc, I think if the number 2 is a set because even an empty set 2 is a set. When it comes to group of set, an empty set is a set. So, like if they say 10 most talented writers in Ghana, it's a definition that they have given, the category of people that you want you to group. So even if you don't even have a talented writer in Ghana, it is also a set because an empty set too is a set. Thank you, sir.
All right. Doc, can I also come in again?
Yes, you can come.
I want to justify what I said earlier on. I consider it to be a set because it is taken as we have selected 10, we have talented subject writers, and among them, the first 10 is being grouped. So it is assumed that we all know that these 10 people are talented. So since we all know, that is where it becomes a set. And also, just as my brother said, if there is none, empty set is also a set. That is why I consider it to be a set.
Okay, that's
Hello,
awesome.
dog.
Doc, I want
Hello,
to come in.
dog. I just want to come in.
Okay, come in.
I want to say that that particular question that we are talking about, sir, is not a set, because that is what my other guy has said. The criteria for determining the most talented writers vary from person to person, and that consider it not to be a set. Because if you go to A to determine the most talented person, it will be different from B. So in this case, it is not well defined. And once it is not well defined, it is not a set. Thank you very much.
Okay, so let us compare the statement 1 and statement 2. What makes statement 1 a set? And what makes statement 2 not a set?
Doc, please, can I come in?
Yes.
Please, if you put the two statements, the statement 1 and 2 to a class, for the statement 1, all their answers will be the same. It will be January, June, and July. But for statement 2, their answers will vary. That's what makes statement 1 a set and statement 2 not a set. Thank you.
So,
Doc.
so I think you are giving very good diverse view
Okay.
of how you are all looking at these two statements, for example. Now, when we look at statement 1, collection of all the months of a year beginning with letter J. So when you ask anybody, the person will give you the months that begin with letter J. So January, June, July. Apart from that, the person will not be able to add any other month apart from these 3 months. So it makes it definite. The answer from a person to a person is the same. And therefore, that makes it a set. Now, as you are discussing, the collection of the 10 most talented writers in Ghana, for example, it's not a set. The reason is that the criterion for determining the most talented writers may differ from person to person. What I will consider as the most talented writer, you may also consider different person. So it's also similar to, for example, in Ghana, when we ask you, or when I ask a class, you should write the 3 best players in Black Star. Are you sure we are going to get the same names from each of
No,
you?
sir. Different.
No, dog.
So that will mean it will not be a set. So if it's to be a set, then the set should be unique, should be very distinct, and it shouldn't differ from a person to a person. That is why that statement cannot be considered as a set. The same way when we look at the third one, a team of 11 best cricket batsmen of the world. For the discussion we are having, it cannot be also a set.
Hello, sir.
When we look at number 4,
Sir.
the collection of all boys in your class, can you consider that one as a set or not a set?
Hello, sir.
It's a set.
It's a set.
Look, there are some people's hand up.
Oh, okay. So let's listen to them.
Okay, sir. I want to ask this submission I want to give.
Okay.
So if as you stated, the collection of 10 most talented writers in Ghana, maybe if you ask me to write a set and I give mine, if I give mine, I think that is the set that I have found.
Yes.
Or
Yes.
so so we were told, then it means what we were told is different from what we are learning today. I thought a set is what you have given, a defined set. Maybe I'm able to list them down to make it a set. Not knowing
Yeah.
it should
So
be.
the fact that you have listed, the set should be unique. You know, the list that you will come out with should be different from the list I will come up with. If the definition we are having is very distinct, that will mean that as long as you will come out with different sets, and another person will come out with different sets, it means that set we are describing is not having a unique description.
Hello, Doc.
Yes.
Yeah, I want to add something. Let's say the best musician in Ghana. We have stated that a set is a well-defined collection of objects. So, best musician of Ghana, somebody can say Shatawale, somebody can say Sarkodie, Stoneboy, Black Sheriff. Since they all differ from person to person, that is why it is not a set. Because we said a well-defined collection of objects. So let's say month that starts with J. When you go to Japan, we are going to get January, June, and July. When you go to South America, the same thing. When you come to Ghana, the same thing. But let's assume that best musicians in Ghana, we just walk around the street of Accra, we will get different answers. That is the reason why it does not qualify to be a set. Thank you.
Yeah. So it's important we need to understand this because we are going to teach our students. So there could be other description when that set is not distinct. And when we say it is a distinct, it means that it's very unique. And it shouldn't change from one person to another person if they are to list the members of that given set. So as long as different persons will have different perspectives of our description of that set, it makes it not to be a set. So when you take number 5, for example, the collection of all natural numbers less than 100. This one, everybody, provided the person know what a natural number is, the set we are going to have will be the same. When we take number 6, a collection of novels written by Chinua Achebe, can we consider it as a set or not a set?
It is a set.
It's a set.
Why is it a set?
So because everybody that knows the novels written by Chinua Achebe can count that number of novels that Chinua Achebe has written.
So it is well defined. It means that when you go enter a library and you are to select the novels authored by Chinua Achebe, when you go and see a poem authored by Chinua Achebe, will you include it?
No, sir.
No.
No, sir.
It is not a novel. When you see a magazine authored by Chinua Achebe, you will not consider it. When you also see a novel written by
Amataidu.
Who?
Amatado.
Yeah. When you see a
Edu.
novel
Amataidu.
written by Ata Edu, you are not going to select it. So this makes the number 6 also a well-defined set. So we are concentrating on the novels authored by Chinua Achebe. The collection of all, number 7, the collection of all even integers. Is it a set or not a set?
A set.
It's a set.
It's a set.
So that leads us to what a set is. That
Doc.
yes.
Please, I think the number 2 can only be a set when it is rewritten as the first 10. That is, when they say the first 10, it means that there is an achievement that is awarded to a number of people, and we have first 10. So we all know the first 10. That is where it can be a set. For instance, when you check on the first 10 richest people in the world, we have names that pops up because this achievement was awarded to them. So I think it is not a set the way the question is being put. But if it is put as the first 10 best writers, that one everybody knows, or it is assumed that these individuals are considered as the first 10. So I think it is not a set due to how it is being put in sentence. But if it is put as the first 10, that is a specific, and everyone will get to know. That is where it becomes a set.
Yeah, and
Thank
even if we say that the first 10 talented writers in Ghana, if you can be even more specific, let's say the first 10 talented writers in 2024 published in
Yeah. Thank you. That's right.
Yeah, published in maybe a certain magazine. Then it means that when we take that magazine, you will have that list there, and everybody is likely to mention those names. So what we are trying to say here is that when we are trying to describe a set, it should be what? It should be well defined. It should be distinct. And also, the object should belong to one kind. Okay. So we say that a well-defined collection of objects in the sense that we can definitely decide whether a given particular object belongs to a given collection or it does not. Thus, a set is intuitively understood to be a collection of well-defined objects. In other words, a set may be considered as a class of objects with the following properties. 1, the objects in the set are distinct. 2, either a given object belongs to the set or it does not belong to. So does a set have a common characteristic? For example, when we look at the number 1 here, given the set E, that is even integers, 4 belongs to E, but 5 does not belong to E. Meaning 4 is an even number, but 5 is not an even number. So it means that when you are listing the element of E and you include 5 in, it makes it wrong. You have to only list the even numbers. So you should have a common characteristic. When you look at example 2, in the set P of prime number factors, of 30, we can say that 3 is a member of the set P, but 15 is not a member. So I believe I'm getting the understanding up to this point. What we mean by a set.
Yes, sir.
Yes, please.
Now, when we are talking about sets, this gentleman here, George Ferdinand Liquid Philip Canto, is one of the pioneers when it comes to the concept of set theory. And he lived between the ages of 1845 to 1918. He is a German mathematician. And you need to also, you are aware of these symbols already. So this one, for the purpose of emphasis, that note that in the set that we are discussing, so that when you see capital,
hey, will you go to the dynasty? Hey, will you go to the dynasty?
Madam Elizabeth, please, your mic is on, please.
So N represent the set of all natural numbers. Z represent the set of all integers. Q, the set of all rational numbers. R, the set of all real numbers. Then when you see Z and you have put plus on top as superscript, it means the set of positive integers. The same when you see minus there, it means the set of negative integers. And Q, when you see plus sign there, it means the set of positive rational numbers. And R, when you see plus sign with it, it means the set of positive real integers. So sometimes we only use the symbols to represent the description of the set that we are talking about. Now, in what ways do we describe a set? There are 4 ways. We have the roster method, we have the defining property method, we have the set builder notation, then D, we have the recursive or inductive rule. So when we take the roster method, aka listing, that's another name. So in this method, the object or members or elements are listed as shown below. So we have set A. The members are 1, 2, 3, 4, 5, 6. Set B. The members are 2, 4, 6, 8, up to 40. Set C. The members are 2, 3, 5, 7, 11, 13. There are some important facts that we need to note when we are describing a set using a roster method. In a roster form, the order in which the elements are listed is immaterial. Thus, the set A above can also be represented as 3, 6, 1, 5, 2, 4. So the order doesn't matter, provided all the elements are listed in the set. Also note that it may be noted that while writing the set in a roster form, an element is not generally repeated. All the elements are taken as distinct. So for example, the set of letters forming the word school will be S-C-H-O-L, not S-C-H-O-O-L. So when the elements are repeated, we have to write only one. Or we can write the set of letters forming the word school as H-O-L-C-S. And note that the order of listing elements has no relevance. So this is the way we describe a set in the roster form. Let's see when... Yes.
Yes, let's go back. It's one, we are learning new things here today. So the second note, you were saying that school, when the letters repeat, you write one, right? Yes. So it means in a question from when it comes like this and it's in a rotor form as SCHOL, we should assume it as SCHOOL. Is that what you mean?
Yeah, so we are asking what letters make the word school. So when I ask you what letters make the word school, you will know say that it is SHOOOOO. So each letter you are counting it once, isn't it?
Yes, please.
So what letters make the word school? So you don't need to say it's SH, it's SCHO and O and L. No. So we are saying that in the rooster form, an element is not generally what? Repeated. All elements are taken as what? As distinct. There.
Hello.
Then another way of describing a set is by defining the property. So by defining the property, you mean here you provide a brief description by highlighting the common property of the element of the set. So when we look at the first one, set A, the elements are 1, 2, 3, 4, 5, 6. Can we write this set by describing it or by defining it? So that means we will look at the set. The set we have there is 1, 2, 3, 4, 5, 6. That is set A. So this one is the listing method, or what we call the roster method. We can also write the same set. We don't want to list them, but we want to describe this element here. So you look at them, then you describe it. So for example, this set in the description form will be the first 6 natural numbers. The same way, when we look at this, the set B, 2, 4, 6, 8, 10. Sorry, 2, 4, 6, 8 up to 40. What description can we make for
first 20 even numbers?
First 20 even numbers.
Step is 40.
Or multiple of 2 less than.
It's 20, first 20.
If for them we
multiples of 2 less than 41.
So
even numbers from 2 to 40.
Yeah, you can also say even numbers from 2 to 40. So when you say that you have given a definite description of the set, then the number the set C, if we are to describe by defining, what will you say? Set of prime numbers.
Prime numbers.
Prime numbers.
Okay, the set of prime numbers. But prime numbers, you still have to be very distinct. Okay, so all these are positive prime numbers, right?
Positive prime.
So we just say a set of prime numbers. Someone may go and include -2, -3, -5, -7. So you have to write a distinct description of the set. Then the next way is what we call the set builder notation. So when we look at our set, our first set that we had, which was 1, 2, 3, 4, 5, 6. We want to write this set in a set builder notation form. So in the set builder notation form, this is the way we can write it. X is such that X is between 0 and 7, where X is a member of what? What's the meaning of that?
Integer.
Where X
That is integer.
Somebody can also describe this as this way by writing that A is equal to X is such that 1 is less
than equal
to X.
X less or equal to 6.
X or less equal to 6. Then you have to define your X. X is a member of
Z
integer, or you can say not natural numbers, or positive natural numbers. Yes.
Sir, please, I have a question on the set builder notation with the A. So
Right.
if you say S belongs to all integers, with the numbers given, you could see that they are specific integers. So instead of you saying S belongs to integers, why don't you say S belongs to positive integers?
Yeah, we can make sure it become more distinct. Agree?
Yes, please.
Okay. Then the number 2, where we were having 2, 4, 6, 8, up to what? 40, right?
40.
Yeah, up to 40. We can also write the set builder notation in this form. That X is said that S is equal to 2n, where n is equal to 1, 2, 3, 4, up to 20.
20.
So that will mean if we want to know the first element for set B, what do we have to do?
You substitute 1 into where you see n.
1 here.
2 times 1.
Then next one we substitute 2. That will be 4. Next one we substitute 3. That will be 6. Next one we substitute 4 in that order. So this is the way we write a set in a set builder notation form. Then the recursive or the inductive rule. Here, element in a set may be defined by recursive or inductive rule. So we give a rule, then some additional few information that will enable us list the members of the given set. So for example, we have a set A, which is A1, A2, A3, up to infinity, where A1 is 1, and A subscript n is equal to A subscript n minus 1 plus 2, for n equal to 2, 3, 4, 5, up to infinity. So this will mean that a formula has been given, and this is the formula for that set. And a few information has also been given about the set, the initial value, and also the domain with which we can use to describe the set. So if you really want to know set A, then what we should do is we use this formula. Okay. We know already we have given the A1 to be 1. So it means our first element is what? Is 1. If we want to know our second element, we are going to find A2. So when we put these 2 here into the formula, we are going to get
A1 plus 2
minus 1 plus 3. And 2 minus 1 will give us A1. Do you agree with me? Plus our 3.
Yes, please.
Now what is
So
A1?
is it 2 or 3?
Sir, it's plus 2.
Oh, I'm testing whether you are following. Yeah, it's supposed to be 2. Okay, so A1 is 1, so you put 1 here plus 2, and that should give us 3. So our next element will be 3. If you want to know the third element, that's a A3. That should be A3 to be equal to A2.
A2 plus 2.
And what is A2?
A2 is 3.
3.
So that
3
give us
3 plus 3, 5.
So that we do that. So this is what we mean by the inductive rule. And I want you to also know that anytime we are representing a set, you use a capital letter to denote a set. So you can't go and say that L is a set. No, small L cannot be. You can't use small letter to represent a set. You have to use a capital letter to represent a set. Then also know that all set except 1 contain element. The exceptional set is which has no element is called what we call the empty set. So when a set has no element, so we call the empty set, and it's denoted by this or this. So please don't go. Let's say if a given set A is an empty, either you write it this way or you write it this way. But don't go and write it this way. Then you again put the empty set symbol in it. Then you again you close it like this. No, don't do this. So I've exercised here for you that when you go take your time and do it. Write the set A, then elements are 1, 4, 9, 16, 25 in the set builder notation form. If this set has been given in the roster form, write it in the set builder notation form. Similarly, this set is also in a listing or roster form. Write it in the set builder notation form. When after you've done that, you compare your answer to mine here. Some aspect you may skip it because you might have done it at the SHS level. You might have also done them in the algebraic thinking. So focus on the areas that you might have not met it before. Is it okay?
Yes.
So subset, please go and read it because we've met it over and over and over. Now power set. Have you met power set before?
Yes, sir. Yes.
Okay. Then go and read that one. What about partition of a set?
No.
No, please.
And then from now going, if I ask you, you'll be saying no, 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 no. But I know what you know. So when I get to where you know, I will skip. But I know what you know, and I know what you don't know. All right. So you are saying partition of set is new to you, right?
Yes, sir.
Yes, please.
Okay. A partition of a set is a family of non-empty subset. So let's underline this one. It's a family of non-empty subset having the following property. Meaning, when we have a set.
Please say hand is up.
Okay.
Please, I want you to increase your volume. It's like I can't hear you.
All right. I don't know whether it's to all of you or him alone.
I think all of us.
All right.
I can
So,
hear you.
I'm increasing my volume. I've not taken my breakfast, so yeah. So we are saying that a partition of a set is a family of non-empty subset. So when you have a set and you are listing all the subsets, and the subset we are listing is set, then we are not going to include empty set. And if they satisfy these two conditions, then we can say that the set has been partitioned. One, subset I should not be equal to subset J. Meaning, when you take any two subsets from a given set, it should be disjoint. They shouldn't have any intersection. And I will illustrate it very soon for you to see. Then condition number two, when we find the union of all the subsets, it should give us the original set that has been given. So for example, if we have a set and the elements are A, B, C, D, then we can form subset from this set. One of the subset is subset 1 can be AB. So AB from the main set. Then we can have another second set, subset to be C. Another third set will be D. Now the reason is this. We should be able to list the subset so that none of them will have an intersection. Okay, so when we find intersection of subset 1 and subset 2, would their intersection exist? There wouldn't be any intersection for this.
No, sir, it won't exist.
The same way when we find intersection of S1 and S3, it will be empty. So it satisfies the first condition that the given subset should be disjoint, meaning they shouldn't have any common element. So first condition is satisfied. Then when you also add all of them, subset 1, subset 2, subset 3, we are going to get back to our original set. So it also satisfies the condition. So that is how we partition a set. And I have some other real life illustrations here. If you can hold on after this illustration and it's still you are not clear, you can ask the question. So let's consider this set. Set F. The elements are 1, 2, 3 up to 12. And if we define 3 subset of S based on a remainder when divided by 3. So we are considering among these elements, each of them that when we divide by 3, we are interested in the remainder. So we define 3 subsets of S based on remainder when divided by 3. Okay. So for example, this set, the element we have listed here, 3, 6, 9, 12. These numbers here, when we divide by 3, there will be remainder 0. So actually we are talking about 0 modulo 3, or we are talking about modulo 3. Okay. Now when you take this one, 1, 4, 7, 10, this will give us a remainder 1, right? When we divide each of the elements by 3. Then we also consider the set 2, 5, 8, 11. The remainder will be 2 when we divide by 3. So the question we are investigating is that, can we claim that this set and this set and this set, that is set A0, A1, A2, can we claim that they are the partition of set S? Can we claim that?
Yes, sir.
Yes, please.
Why so?
Sir, because
all the
but when you sum them, they'll be equal to the universal set.
Yes.
So that's the meaning of what we mean by a partition of a set. Now, let us also, so that's the explanation you have given. We can see that one, when we take any of the sets, the subset, A0, A1, A2, they are non-empty sets. And that defines what we mean by partition of set. Say, a partition of a set is a family of non-empty subsets. So in the first place, it should be non-empty subset. And 2, it should be disjoint. And 3, the union should give back the original set. So when we find the intersection, the pairwise are disjoint, meaning they don't have intersection. Then when we find the union, we get back the original set. Therefore, we can claim that set A0, A1, A2 is a partition of the set S. Another illustrative example of a partition of a set is, let U be the set of all mathematics students in the School of Education at UCC in a given year. We classify each student by their program level. So level 100, set of all level 100 math students. Level 200, set of all level 200 math students. Level 300, set of all level 300 math students. Level 400, set of all level 400 math students. So we have a set P, which is made up of level 100, level 200, level 300, level 400. Can we claim that set P is a partition of the universal set, where the universal set is the all mathematics students in the School of Education? Can we claim that?
Yes. Yes, please.
Yes.
Yes, please.
So this is the elaborative illustration. So in practice, each level has at least one registered math student. So there wouldn't be any non-empty set. Then pairwise disjoint. There's no way that a student can belong to level 100 at the same time level 200. So pairwise disjoint, pairwise sets are disjoint. Then when we put all level 100, 200, 300 together, we get back the math students in the School of Education. So that gives us what we call a partition of a set. Okay. Any questions so far? The one who wanted to ask questions, are you now better? Or you still have some questions to ask?
Yes, please, I'm okay.
Right. So before we go on, let us look at this activity here. State which of the following set are finite or infinite. So the number 1, will you say it is finite or infinite?
Sir, it's finite.
Finite.
What is your decision? Why so?
Sir, the reason is that it has a set of 1 and 2 when you do the computations.
So 1 and 2. So that makes it finite. Okay, I agree.
It has definite number of members.
And the II.
It's a
also finite.
It's a finite. What are the elements?
Positive
negative
2
and negative 2.
and the negative 2.
Negative 2 and 2. Okay. Do anyone has different view about this list as far as number II is concerned?
Sir, the set is 2.
The set is 2. Someone is also saying the set should be only 2. Why?
Yeah, two. Positive to natural numbers.
Yeah, because we are dealing with natural numbers. So always look at the definition, look at the description before. Don't be in a hurry to draw conclusion. So the element can be this. It's only 2. And that makes it also, that makes it a finite. Now let's look at number 3. Is it finite or not finite?
Infinite.
It's infinite.
Why are you
It's finite.
Why are you saying
It's
infinite?
finite.
It's finite. It's finite.
Yeah, we are
Because
talking
it
to
is an
ideas
empty
here.
We are talking about natural numbers.
Finite.
Can I
Yeah, you can come in.
say, please? It is finite because it is an empty set. And when you talk of natural numbers, you get the answer as you have S value to be half, and half is not a natural number. So here it becomes an empty set.
An empty set. An empty set is finite, so therefore it's finite. Okay. Number 4.
Infinite.
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 Reason.
Because the set of natural numbers, the prime numbers, it doesn't end. It is up to infinity.
Okay.
And the last one is infinite.
Infinite.
Okay. So it means that you already know the meaning of finite and infinite set. Since you have been able to do that, so I'm not going to repeat it. Right. The next thing is operation on sets. Union of set, you know it already, so you will skip it. I believe you agree with me.
Yes, please.
Yes, sir. Yes.
Yeah. One thing I will stress is that
sir.
Yes.
But when you add a little voice to it, it makes it unique. So I wish you could have add something small.
Madam Fukujata.
Sure.
The way I will add is this illustration that when we are finding the union of 2 sets, 2 basic situations can occur, and one of them can be this, whereby we are adding 2 sets. Now these 2 sets, sometimes their intersection can be empty. It's possible. Do you agree with me? So the union of sets whereby their intersection is empty can be represented as this. Then there should be also a scenario where the intersection of the 2 is not empty. So like this one. Okay. So we can say that set A is not a proper subset of B. Then when you look at this diagram, you can see that all the members of B can be found in A. So B is a proper subset of what? Of A. So these possible scenarios can occur anytime we are talking about union of set. The next operation of set is the intersection. And for intersection too, you are good at it already, so I will not talk about it. But we can have some cases. So just like the union, there are 2 situations to be considered when it comes to intersection of set. It is possible that sometimes the intersection of 2 sets can be empty. This scenario is possible. Then there could also be scenario that the intersection will not be empty. Now, in the situation where the intersection will not be empty, we can have this, where A intersection B can be equal to B. That will mean all the members of B can be found in A. In a situation where we have a proper subset. We can also have a situation when we don't have a proper subset like this. In this situation, the element can belong to A and B, as illustrated in this diagram. Then we can have information whereby the element in A is the same as element in B. So that's
Doc,
this way.
Doc, in a situation in the I, can we say A is a superset of B?
Yeah, because yes. So the next operation of set is the difference between two sets. And difference between two sets is denoted by this. So if you want to find the difference between set A and B, then we write A minus B. And it is defined as this, meaning X belongs to A, but does not belong to B. Or we can write it as A intersection B prime. So for example, if you have set A, and it is 1, 2, 3, 4, 5, and set B 2, 4, 6, 8, 10, then A minus B or A difference B are those elements that are in A, but they are not in B. And what are those elements that we can find in A? They are not in B. It's 1,
3,
3,
5.
and 5. So A minus B is this one. So on the operation of set,
Sir,
yes.
the same example, can you also find B minus A?
Yeah, you can also find B minus A. So B minus B, A means that it should belong to A, so it should belong to B, but not A. And what will be those members?
8 and 10.
It will be what?
8 and 10.
8 and 10, okay. So take note. These are some notations for you to revise. Then these are some shaded regions. I want you to write the set for them. Try them first. After trying, compare with my answers here. Now the next thing we are considering is the theorems. So we have theorem 1, and theorem 1 is on subsets. And we have reflexive property of inclusion. So when we have a set, we can say that a set is a subset of itself. I believe you agree with me.
Yes, sir.
Where all members of set belong to the investor. Then we also have the transitive property. So if set 1 is a subset of set 2, and set 2 is a subset of set 3, then you can say that if it's a subset of set 3.
Mr. Osu, please, your mic is on.
And that is the transitive property. So we also have the equality set. And under the equality set, we have the reflective property of equality of set. A set is equal to itself. Then we have the symmetric property of equality of set. So if set 1 is equal to set 2, then we can also say that set 2 is also equal to set 1. Then the transitive property of equality of set. If set 1 is equal to set 2, and set 2 is equal to set 3, then you can say that set 1 is also equal to set 3. Then we have, yes?
Sir,
Yes.
sir, please, can you help me with this? That letter or that symbol which looks like A, which is being turned. How do we call it?
Yeah. Said that all the set, so all set 1 and set 2 belongs to the universal. All.
Okay. Thank you.
Then we have also intersection. So the theorem 3 is on the intersection. And we have the idempotent property of intersection of set. You know, every set is an intersection of itself. So this one too, so basic. The symmetric property of intersection of set. Set 1, if set 1 is intersection, set 1 intersection set 2 will also be equal to set 2 intersection set 1. Provided all set 1 and set 2 are subset of the universal set. So theorem 4. If set 1, set 2, and set 3 are subset of the universal set, then we can have these properties. And I want to also learn the proof. And when you are going to prove this, don't go and use fixed numbers. You know, for example, if I ask them to prove this, some will begin by, okay, let set S be maybe 1, 2, and 3. Therefore, we find the S union S, and they will get back the same thing. Don't use specific example to do the proof. When you are doing the proof, you have to use arbitrary. So you can consult any of the AI tools like ChatGPT, and you learn how each of them is proved. So let me illustrate one for you to see. I can discount it. Let me show my entire screen. What is it? Okay, stop sharing. And let me reduce my entire screen. I believe you can see my screen. So let me, I'm just showing one example for you so that you know what I want you to do. You are going to learn the proof by yourself by relying on the AI technology. So for example, let me come to the slide. Let me take this one. So when you come to you open your chat GPT, or either you are using Copilot or whatever technology you are using, just type in this one. Proof this set theorem. So let me. I believe you can see my screen.
Yes, sir.
Yes, sir.
So prove that S1 union S2 union S3 is equal to SU da 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 da. So here we show mutual inclusion. Each is a subset of the other. So to show that, you see how he began. So we have chose arbitrary number X. We say let S equal to this. Then by definition, if S equals to, then you can say that S is a member of this or S is a member of that. If S is a member of this, then S is a member of that, and S is a member of that. So it follows that until it is. So you could say that he's not using specific numbers, like I was indicating here. Like I was indicating somewhere that some of you will go and list numbers and use it to prove. No, I don't want that. So kindly use the AI and do the rest of the proof here. Are we good here?
Yes, sir.
Okay. So I will ask you at appropriate time, any of them, either in a quiz or exams, prove that. Prove one of this. So the homework is that learn the proof of all the theorems. Now, De Morgan's law. So the De Morgan's law, there are two. We have De Morgan's law of union and De Morgan's law of intersection. You have learned this one in your algebraic thinking. Am I correct?
No.
One castle.
Yes, we learn it in algebra.
When did we learn
We
it?
learn it in algebra.
All right. So this one, when you take this one for example, this is the De Morgan's law of union. So A union B complement is equal to A complement intersection B complement. And the proof is also here. You could say that I didn't use numbers to prove. I used an arbitrary number. And let's look at it this way. If you want to prove this, we can prove from left to right or right to left. So we let P to be equal to the left side. That's it. A union P or complement. Then we let Q to be equal to A complement and B complement. That is the right side. Now, if we take the left side, we want to say that we want to see that if we manipulate the left side, we can get the right side. So we let S be an arbitrary element of P, where X belongs to set P. So X belongs to set P. So if X belongs to set P, it implies that X is a member of A union B or complement. Now, if X is a member of A union B or complement, then we can say that X is not a member of A union B. Does that make sense?
Yes. Yes, sir.
Yes, please.
Yes.
Then if X is not a member of A union B, then we can say that X is not a member of A or X is not a member of B. Does that also make sense? Okay. The next thing is if X is not a member of A, then we can say that X is a member of A prime. And X is also a member, if X is not a member of B, then we can also say that X is a member of B prime. Now, in set, what is the meaning of AND? AND means union. So therefore, we can now say that X is a member of A prime, intersection B prime. So you could see that from the left side, we have proved the right side. So the next thing you do is that you now also take the right side. Then you also show that it's equal to left side. And that is what I have done here. So I want you also to go through this one. And similarly, I've also done the De Morgan's law of intersection. The proof is also here. So based on the first illustration, you can follow through to also do this on your own. Of course, you can still rely on AI to also learn more on that. Great. When we were writing the expectations, some of you wrote that by the end of the unit, you will be able to solve programs related to 2 set and 3 set programs. So this is what we are going to do. Now, before we start, let's look at this set. You know, when we have a set, suppose this is set A, suppose this is set B. You know, where I have shaded is what we call the A only. Do you agree with me?
Yes, sir.
So the A only, meaning that we are interested in the element in A but not in B. And that is what we call difference of two sets. So where I have shaded can be also represented as A minus B. That is what we have done here. Then you also agree with me that this side is the intersection of A and B. So where the arrow is A intersection B. And similarly, this side is B only. And B only means element in B, but not in A. So that will be B minus A. Now, when we understand this way, we want to prove that when we put the number of A and B together, it should be this one. That number of A plus number of B minus number of A intersection number of B. And this formula is very popular. Have you seen this formula before?
Yes, sir.
Yes, sir.
So we want to prove it. Why it is so. So to prove that, if A and B are finite sets, then we can put all of them together. So we say the set A minus B, meaning here, A intersection B, meaning here, and B minus A, that is here, are disjoint. Do you agree with me that they are disjoint?
Come again, sir.
Do you agree with me that here, the set here, and the set here are disjoint?
Yes, sir.
Yes, please.
Okay. So when you agree with me, then we can find their union by putting them together. So if we are putting them together, it means that number of A union B will be equal to number of A minus B plus number of A intersection B, meaning here. So here plus here plus here will give us this equation. And we should bear in mind that we want to prove this. So from this equation, how do we get this? So what we are doing is I have just maintained, so we have this, we have maintained it here, we have this, we have maintained it here, we have this, we have maintained it here. Now, algebraically, what we are doing is that we have added zero identity to this equation. And what do we mean by zero identity? When we add number of A intersection B minus number of A intersection B, this will give us zero. Do you agree?
Yes, sir.
So invariably, it's the same expression that we have maintained. But because we want to reach this formula, putting this identity here is very useful. Therefore, from here, we have to manipulate it. Do you agree with me that the elements here plus the elements here will give us the A? Do you agree?
So we can see your point.
You can't see where I pointed. I'm saying
Yes.
that when we put the elements here plus the elements in the direction here, when we put them together, we will get set A.
Yeah.
Yes,
Yes.
sir. Yeah.
Okay. So that means number of A minus B plus number of A intersection B, the whole of this.
Okay.
Should give us A.
Okay. Okay.
Again, the whole of this
Okay.
should give us B.
Sure. Yes, sir.
Until
All
aka
right.
we for aka minus we I see the back. So the formula is proved.
Yes, sir.
So this is how that two-set problem came about. So are you picking something new today?
Yes, sir.
Yes, sir.
Right. So that is how it is proved. If we want to show that number of A union B is equal to number of A plus number of B, then it means that this will happen only when the intersection is equal to 0. So when we have two disjoint sets, their union will be this. So also take note of that. Now,
sir, question.
right.
Sir, please. The second stage of the proving, where we have number of A minus B plus number of A intersection B plus number of B minus A. Now I understand where we got those from, but the added ones, that is number of A intersection B minus number of A intersection B. I'm a bit confused how we got those ones.
That is algebra. When you number of A intersection B minus number of A intersection B, what is it equal to? That would give us 0, right?
0. Yes.
Yes.
So you
It will give us 0.
have not altered the original equation.
Okay.
So we added to enable us achieve our goal.
Okay.
And that's
Okay.
where the algebraic thinking will come in. You have to think algebraically.
So it's a way to be able to prove the formula.
Yeah.
Okay. Thank you, sir.
So if we understand it that way, then we can also prove the three-set program by developing on the proof for the two-set program. So if set A, B, and C are subset, prove that number of A union B union C is equal to number of A plus number of B plus number of C minus number of da 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 da. I think I've made this formula somewhere before.
Yes, sir.
So, Doc, would it be in a question whereby they can ask you to prove this three-set problem and what?
Yeah, it's possible. Once you understand, it's possible. Okay. So I've done the proof for you here. Take your time and go through, but I can just give you a brief hint so that when you are reading, you understand.
Yes, sir. Give us a brief.
So the hint is this. Hint. We have already proved that A union B is equal to, do you remember the formula? Number of A.
Number of A
minus
number plus number of B
minus
number of A intersection B.
intersection B.
So this It's very powerful. It's going to be helpful. So what you do is that we are going to use the same definition to prove the three-set program. Until OPA, consider all this as B. What was that? So when you consider all this as B, then you are going to rewrite this one in the form of our formula.
Okay.
Between whatever you see B, put B union C.
Okay.
This one. So that's what we have done here. So when you write that, you could see that when you also take here, it looks like this. So also define this by using this. Then when you finish, also come here and also define by that. Also define after that, put them together. And when you put them together, you arrive at this. So that
please,
is the
come again. The hint again.
The hint is there already. So use that and navigate through it, and you'll be successful. So having gone through the proof, now let us solve programs. Let A and B be two finite sets set that number of A equal to 20, number of B equal to 28, number of A union B is equal to 36. Find number of A intersection number of B. So this one two-set program, right? So we can write the formula down. Then the formula is given by this. Then we substitute in the values. Then we solve for the unknown. So we were given the union, we were given this, we were given this, and we were asked to find this. So you make this the subject. And there you go. Is it okay?
Yes, sir.
Another way you can do this is by also drawing the Venn diagram itself. Like that. So we have A, we have B, so A, we have B. So in the question, we have been given A to be 20. We are giving B to be
28.
Then we are giving the universal to be
36.
To be 36. So you can solve this. We are looking for the intersection, so you put S here. So between here will be 20 minus X. Remember. And here will be 28 minus X. So you solve this. Now you know that when you consider set A, all the elements, when you put them together, it should be 20. So we can write 20 plus, then we take the other element left, which will be 28 minus X equal to the universal, which is 36. So we are solving for S. 20 plus 28 will be 48 minus X equal to 36. So what will be X?
12.
S will be equal to 48 minus 36. That will be equal to 12. So I have interesting questions in that I will encourage you to go through them by yourself. And please, each of the programs, solve them first on your own. After that, compare with my solution in the slide. So each of them, do it first, compare with my solution. Each of them. Some of them are quite challenging. When After you have practiced all that I have in the slides, I have also a link here. Click on this link and also work more. There are more examples here. I want you to work by yourself. So this brings us to the end of the unit 3, sorry, of the unit 1. What new thing did you learn today? What new thing did you learn today, my students?
Hello, Doc.
Concern. Yes.
Hello, Doc.
Yes, you have the floor.
One new thing I've learned is under the operations of partition of a set.
Okay.
It's one of the new things I have learned.
Right.
Then how to prove unions and intersection of two sets problems and three sets.
Okay. So value for money. The school fees you paid, you've got a new idea. If you
Okay,
are here,
Doc.
your fees, go and pay you.
Okay, Doc.
Yes, Jeremiah.
Yeah, one new thing I learned today when it comes to the listing of the set, it is that it doesn't matter how it is arranged. It can be arranged anyhow. Either 2 will come before 1 or 10 will come before 7. That's one thing I've learned.
All right. Any more? No. Yes, Dominic.
When I learned to do the Morgan's law, maybe it's my first time of seeing it.
It's said by the alpha. Today, B plus and the plus for the all for the different numbers. Right. So that is good. I'm going to share the slides with you. Go through unit 2 and unit 3. Next week we will discuss unit 2 and 3. Today is just the opening. If next we're able to the 2 and 3, yeah, it's likely we can finish. So ensure that you go through them, note your difficult areas. When we come, I'm not going to take you through like I've done today. We will project the unit 2. Then I ask you which areas you have difficulty. And please don't say the whole show. When you tell me the whole show, it means you didn't read. And I will not.
Doc, I have something to say.
Yeah, I'm coming.
Concerning the.
Please read them, use the whole week to read the unit 2 and 3. So that when we meet, we can do it faster. Then you can go and do your activities for the day.
All right. Thank you.
Any observation? Comment?
Sir, please, how many units are we doing?
We are doing 7.
Okay.
Sir, please, look, at times the slides will be given, then it will be explained in details like how you have done it. You understand everything, but when it's time for exams and quizzes, then you will see different questions altogether that you have never met. A typical example is the algebraic thinking, whereby we met questions where we think we have never taught anything. So if you can kindly come together with I think the lecturers who have been teaching to, let's say, set questions within what we have been taught, but not outside what we have been taught. Thank you very much.
That's why course outline is very, very important. Your questions are going to come from the course outline. If you need to. All right. Okay, so on that note, let me see what I want to do. Why I can't share my screen? Oh, okay.
Dog.
Hello, sir.
Yes.
Sir, please, I would like if you get the slide you were writing on. If you will get the actual slide you were writing on, the one with your ink.
Oh, I've discarded it all.
Oh.
I've discarded the. It was asking me to do I want to save it. I said no.
Oh.
So all the one is gone.
Say, can never boy power.
And anytime I say the active student, sit behind your table. So as I'm doing key things that are important, write them down.
Sir, I was doing that, but it was fast. Yeah, that's why.
The next time, please, you give us that one.
Next time, screenshot to the one. You think?
If someone has the screen, all of the screenshots, you can share it to us.
Hello, Doc. I have WhatsApp you for the materials.
Is your last number 22?
No, 79.
Okay, I'm looking for it. 79. Okay, 79. Isa Alfred, right?
Yes, Doc.
Okay, so let me share.
Okay. Yes.
I believe you can see my screen.
Yes, we enjoy your screen.
I'm sharing all the units.
7 units.
From today up to next week, do justice to unit 2 and 3. That will be the focus for discussion next week.
Okay.
I wish you the best.
Thank you.
Bye-bye.
Thank you, Doc.
See you next week.
Hey, Mr. Peterson.
Yes, about.
I can see you.
Jose.
Yo, what's up? What's up? What's up? Utama.
Please, which unit did he say we should focus on for that discussion?
Two and three.
Okay, thank you.
So I'll be forwarding the message to the group.
I'm not in the group, so
please, you DM me, just DM me so that I'll add you. So give me your contact. 0248 66 11 26 or 36 0248 66 11
Mr. add me. Please, you can also add me.
Name
059.
059.
Hello, guys. Please, why are we creating another platform?
958.
No, some of them are not in the group.
No, we are not creating another platform.
059
407.
Why don't you just give your number so that they will do you high on WhatsApp?
Very well.
That one will be better, bro.
024 125 4279. 024 125 4279. 4279.
Mr. Isa.
Yes.
Will Madam be able to meet us?
I just want to call her right now.
Okay.
I'll be calling her.
Okay, then find out from her
and get back to you.
I said to do what?
Okay.
Hey, you don't should be your first and last. Hey,
Hello?
you should be first and last. If you want to go out, take permission, you go out.
Yes, yeah,
But
please take my number and add me to the group.
if you want to go out, tell me before you leave. Okay.